It's my pleasure to introduce AeroShield materials, where our breakthrough in material science is enabling the world's most efficient solar thermal energy. For the Solar Prize, we have partnered with Aerogel, whose engineers have over 40 years of experience designing and installing solar thermal systems. When you think of renewable energy, you naturally think of electricity. Huge strides have been made to make U.S. electricity generation nearly 20% renewables and growing. Separate but equally large is the U.S. demand for industrial process heat. That's the heat to pasteurize milk, run furnaces, or process food, and has been stagnant at 10% renewables for over a decade. It's dominated by natural gas, and even the renewables come from the combustion of biomass or biogas. To produce renewable industrial process heat at 250 Fahrenheit, you could use photovoltaics and an electric boiler. Top-of-the-line PV panels would allow you to do this at 20 to 25% efficiency. AeroShield's super insulating transparent aerogels enable the direct conversion of sunlight into heat at up to 60% efficiency. And as an added bonus, thermal storage to support the system can be 90% cheaper than battery storage. So what would this look like? A flat plate receiver looks a lot like a PV panel installed on a rooftop or small-scale distributed system. Instead of a wire carrying electricity, though, we use pipes carrying steam or hot water. The working principle of a solar thermal receiver is quite simple. An object left in the sun will get hot, but as that object heats up, you get thermal losses that hurt your efficiency. At the collector surface, you need a material that allows light to pass but no thermal energy to escape. What you need is transparent insulation. AeroShield manufactures the world's most transparent silica aerogel, transparent insulation. Aerogels are some of the most insulating materials ever created, they're super light, and they're fire retardant. But they've always been blue. For the first time ever, AeroShield is making aerogels that are transparent, and this creates a step change in performance for solar thermal. Foundational work showing that transparent aerogels can improve solar thermal efficiency was done at MIT and published in ACS Nano, and AeroShield's founder, Dr. Elise Strobach, is one of the inventors of the material. The American-made Solar Prize has allowed AeroShield to accelerate our development. Since our application, we have brought online a new vessel and scaled up our manufacturing, had samples tested and performance validated at NREL, hired a new process engineer, improved yield, and had a third party create a techno-economic analysis that validated our long-term cost models. We also partnered with Aerogel, which allowed us to look beyond aerogel manufacturing into receiver design and system integration. During this time, we've also built a CFD model to estimate system performance, created a CAD model of a 50 kilowatt system, built out a bill of materials, designed, tested, and built an absorber plate receiver control system and test rig, built a first prototype, and finally took a second to relax while doing an on-sun demonstration in sunny Florida. This on-sun demonstration was run for a week and validated our model and lab-scale test results while also proving the aerogel could handle environmental conditions. Our bill of materials and modeling indicate that even a first generation of flat plate collectors could provide distributed rooftop thermal energy for an LCOE of around 7 cents per kilowatt hour. While this leaves solar thermal more expensive than natural gas, it outperforms rooftop PV, with the additional benefit that storage is far more economical and no electric boiler retrofits are required. Most importantly though, the aerogel is just a fraction of the total system cost. Solar thermal has not seen the efficiencies of scale and standardization that PV has seen, indicating that scale could provide a path to cost competitiveness with fossil fuels. Thanks to the American-made network, we were able to fast-track our market discovery and better understand our market potential with warm introductions to end users, product development experts, and national labs. We were able to identify our beachhead markets and receive letters of support from manufacturers involved in concentrated solar power and flat plate air heating, contractors who have designed and built solar thermal systems, and end users representing use cases such as brewing, the military, and water desalination. All recognize the need for renewable thermal energy and the advantages that creating it directly provide. AeroShield is led by Dr. Elise Strobach, inventor of the AeroShield material, and Dr. Kyle Wilkie. Our advisors represent decades of experience commercializing aerogels and glass technologies, and working with Aerogel brings more than 40 years of experience in solar thermal to the team. So what's next for AeroShield? Solar thermal receivers are the first on a longer roadmap of energy-efficient insulated products for AeroShield while we scale up manufacturing. This month, we begin installing new equipment to enable larger sheets, and advancing to the next round of the Solar Prize will allow us to work with Sandia National Labs to test these sheets, optimize our receiver design, and further explore thermal storage options. We are incredibly excited about this opportunity, and a big thank you to the entire American-made network for your support.